Now that our consumer application has successfully written all the files in our S3 bucket, we can close our consumer application. But in a real world, our consumer application will be always alive, and it will take a data and write it into a specific topic from the producer, whatever it writes, right? Whatever your producer writes, it will go and write into a specific topic. And your consumer will be always alive, and it will keep reading data from your Kafka topic. But since we have very limited amount of data, we can close our consumer application as of now. So now our data is steady in our staging layer inside our albums, artists, and tracks. Now we need to take this data from staging layer to data lake. We could have directly run a glue crawler in our staging layer and started consuming it through Athena. But what problem it causes is we have small files, right? When our consumer application will keep on writing to our albums, this small file will be large in number. In a day, now when you are running, we can see 100 files. When you are done running for a whole day, it will create thousands or lakhs of files, right? So we cannot do this. We have so many small files because our Athena will not be able to read such small files. Hence, what we do, we take all this data from staging layer and write it into our data lake. We can partition it there. We can partition by date. Let's say today's data will be written in one folder, then tomorrow's data will be written in another partition. We can do that, but since we are doing for only one day, I will not be creating partitions. Now we can do many other things as well. We can read a data from albums, artists, and tracks, and we can create one big table, right? Otherwise, we can create three different tables, one for albums, artists, and tracks, right? But for this project, we'll be creating one big table. We'll take a data from all these three, join it, and write it into our S3 data lake. That is here. Okay, now let's go ahead and start our glue. Bucket. Let's go to glue. To start creating our ETL job, we can create a visual ETL, right? Now visual ETL is a recent feature which AWS Glue have launched. Herein we can just drag and drop and create our ETL pipeline. So we have raw S3. Let's read tracks data from here, right? Our browse S3, we can go to our staging layer and we can go to my tracks and choose. Now we can just do CSV file, and now I can see that we have to assign a IAM role first before viewing, because we need to give access our glue the EC2 access, right? So what do we need to do? We have already created one role, but that is for EC2 instance, but for now I need for glue. So let's go to IAM. Let's go to roles. Let's go to create roles. We need to choose glue, right? Now next I need to search for S3. I can provide S3 full access. Now this glue to S3, right? This way we will be able to create our IAM role. Now if I go to AWS Glue and now search, no roles available. We need to refresh a page. Let's refresh it. Source AWS S3. Let's do for tracks. Let's browse the data that is there in staging layer, tracks, right? Now our format is CSV, right? We need to provide an IAM role. I can see glue to S3 here. Now we can see that it has started seeing the data and it will give a preview of the data whatever is present. Now we have data in three layers. One is tracks, one is albums, another is artist, right? So inside staging I have albums, artist and tracks. So we need to create three sources here. Let's create one more source and one more, right? Here I can give artist. Let's I can browse staging. I can provide a path as artist, then format to CSV. It have started filtering the data. Same way let's do it for, we have done for tracks, artist, albums. Let's go to browse S3, let's go here, and albums. Let's choose CSV. Now all our three sources are ready. I can see the data here. It is still reading because there are lots of small files. It is taking time. So now what do we need to do? We need to join these two tables, right? So what do we do? We add here. We have a transformation. We need to join. So what all tables we need to join? We need to join these two tables, right? So copy it here. Now we need one more join, right? So what all we'll join? We'll join this table and whatever we have got from here, right? This way we'll perform a join. Now once our join is done, we will write our data to our S3 bucket, right? Now this is all my ETL will look like, right? So let's see whether our data is ready or not. I can see my data is ready. It has successfully read track ID and track popularity. Same way for artist, it has got ID, name, artist popularity and follower and so on. Okay, now we have done one mistake, that is albums must be here and artist must be here, because albums and tracks have a track ID, right? So to do that, let's change the path. Let's set it to artist and change this name to artist, right? And change this to albums and change this name to albums. Now we can go to our join condition. We can add a condition. From tracks we need track ID. From albums we need, I guess it has not still read the data properly. It is still reading the data. Let's wait for some time. Albums, yeah. And now custom prefix inner join albums as track ID, right? So track ID from tracks table and track ID from albums table will create a join. Now we have inner join add condition. From artist table we have artist ID. Join here also will be a artist table, artist ID. Now after join, we have a S3, but we need to do something else. One more. Let's delete this as of now, right? When we are joining here, we can see there are some unnecessary column name which have been created, that is dot track ID and all. Let's go ahead and remove that. Transformation, there must be somewhere drop fields. Yeah, we have drop fields. Let's go ahead and drop dot track ID, and this also we can drop. I guess this ID is what? This ID is used to represent our artist ID, and yeah, correct. Now we already have artist ID, so I don't need this ID. This is same as artist ID. All the other things is important. Now what we can do, we can write this data to our S3 bucket. That is, we can point this to S3. This is why it's not getting pointed. Oh, sorry, this is a source. We need to create a destination bucket. Target S3 target. Sorry. Now we can copy this and write it to here. Now we need to provide a path for our S3. I can go to data lake and just put the data here. Right, now we can choose the format in which we want to write a data. Since this is used for analytical purpose, we can make use of Parquet. So let's write job. Now I can save this. Now we have got a visual ETL, right? Now if you need some complex transformation all, we can also make use of script. See what visual ETL basically does, it will help us to create a script without actually coding it, and it's making our things easy. But if you need to do some complex transformation and all, we may need to edit the script. So visual ETL is only available in the beginning stage. Once your first stage is done, post that you will not be able to make changes using a visual ETL. Now if I save, now our job is successfully saved. Now I can run the job. Now to check our job monitor, I can go to job runs. I can see the runs. Now I can see that it is running. So you can also change your job detail. As of now, it has automatically fetched Python 3, the worker type, all these things it has successfully fetched, and it has assigned a number of workers as 10. That is the default number of workers. You can change as per your wish. Job time what is set to 2880 minutes. Now we can, the ETL will run for some time. It will take some time to run.